Hello everyone, today we're going to talk about element number 18, argon. Argon is the next noble gas down from neon and helium. It is an inert gas, which means it's in the air and it doesn't react with anything or any atom chemically. That allows us to be able to breathe it in without even being able to notice that it's in the air. In fact, it was recently discovered. Sir William Ramsay was a great contributor. In fact, he contributed towards the discovery of these various noble gases: helium, neon, argon, krypton, xenon, and radon. We will eventually get to krypton, xenon, and radon in the next upcoming videos. Argon has 18 protons, 18 neutrons, and 18 electrons. It consists of 1% of the air that we breathe. It consists of, as you can see, other gases, mostly argon. So the majority of the air that is not carbon dioxide, oxygen, and nitrogen is argon, and it is unreactive with the elements from our body and allows us to be able to breathe it without dying, because if an element is reactive, such as the element chlorine, the element that is before argon, in fact, it will react with the lungs and it will react with the environment. So it's very important that argon is a noble gas, because anything more or anything less changes the property of the atom altogether. And that's why it's important to understand the atomic properties of every element, because that determines everything else about the element. We're going to talk about its properties, we're going to talk about its history, we're going to go over a few key elements. Here's the air separation. This is how we get argon liquid from the air. As you can see, it's 0.93%, about 1% of the air. It's mixed with the nitrogen in the air. So we're about to endeavor on this journey, and we're going to talk about how argon interacts with everything. As you can see here, argon glows. When argon gets excited by a high voltage current, it starts to emit visible light that we can use for light bulbs or other devices that we need for light. Argon has been around for much longer than its discovery date in 1785, when Henry Cavendish isolated the gas for the first time, not knowing that the remaining 1% of the air that was left in the container was actually a new element that was eventually going to be called argon. So in the air, there's nitrogen gas, there's oxygen gas, there's argon, neon, krypton, xenon. This is methane, this is H2, this is helium, this is carbon dioxide. There's also various other gases, but they're so small in quantities that they don't affect us in general. So argon, it consists of 1% of the air. So eventually, after Henry Cavendish filtered away the nitrogen, the oxygen, the carbon dioxide, maybe he didn't even filter these away. Maybe they were just in small amounts of concentrations, that the argon was the predominant noble gas that didn't react with the environment. Maybe these were also mixed in as well. So he eliminated the majority of the gases and the compounds that were already identified and classified, and left only the mysterious 1% air that nobody knew what it was. So fast forwarding to 1894, Lord Rayleigh and William Ramsay first separated it from liquid air in a similar way to Henry Cavendish, only they did it differently and they were able to identify it, they were able to classify it. Argon comes from the Greek word inactive, which is an appropriate word for the element because it doesn't react with any element in its environment or surroundings. Although it's present with every other molecule that we know and recognize today, it doesn't interact with it because it's a noble gas. Again, as previously stated, the element before it is chlorine, a very reactive element that reacts with its environment and makes compounds in various ways. In contrast, argon is independent as a unit, and as an atom it can be stable by itself. It doesn't need a bond to anything, which explains why it doesn't bond to many things in nature. The only way we could get argon to bond with other things is if we mix it with a super reactive electronegative element, such as the element that we discussed in one of the previous videos, fluorine. The link is in the description below if you want to jump into a portal and view that video. So they made it into a liquid, they distilled it, they were able to classify it as a new element because they were able to change its state. They separated it from liquid air, so they made it into liquid argon, they made it into solid argon. They were able to decrease its temperature enough to be able to classify it and identify it in history. Because argon is a noble gas and doesn't react with any other elements in the environment or in the air, it's used as a gas for welding, similar to the way that helium is used for. As stated here, it says a blanket of argon or helium is used in between as the filler rod metal is being inserted and heated to a high temperature. Because when metals are heated to high temperatures and they're exposed to the air, they have a higher probability of oxidizing, and a lot of the metal oxidizes oxidizes more quickly because the metal allows the heat to come into greater contact with more amounts of oxygen, and it allows it to oxygenate at quicker rates than it would otherwise at a cooler temperature. So by having these unreactive gases as clouds that encompass the metal when it's super hot, it allows the metal to remain protected for the time that it requires protection while it's cooling down, so it doesn't oxidize immediately with the air, and you get fresh unoxidized liquid, now solid metal in whatever substance or material you wanted to apply it in the first place. Argon is used to weld metal such as titanium and various other strong substances that require insulation from the molecules of air around it, such as nitrogen, hydrogen, oxygen, and other reactive compounds that have the potential to form other molecules that are unnecessary for the welding process. Argon lasers are used in the healthcare industry. They're used for retinal phototherapy, and they're also used for retinal detachment, so they're used for various things involving the eyes. And lasers are very precise, so whatever the lasers are used for, they're able to be targeted at specific areas of the eyes that without lasers we wouldn't be able to be that precise. So it's important that we have these argon lasers because they're used for everyday life and helping people improve their vision. So once again, argon gas is used for welding because it's a very unreactive atmosphere. That's why it's also used in the middle of glass planes. In fact, if you have a glass plane with something in the middle that's just air, most likely it's filled with argon gas because it's an unreactive element that conducts heat very poorly, so it allows the insulation to take place between the house and the outside environment. Argon, being such an inert gas, is used for various types of preservation, such as wine preservation. Seen here, we have a canister of argon being pumped into a glass of wine that then replaces the air within it with argon gas that is more inert and doesn't react with the wine itself, causing it to lose its potency. Here is another image depicting argon gas being inserted into a wine bottle. It's called the Wine Save Pro, but it's just another way of packaging the argon gas, which doesn't react with the environment within the bottle, because usually you would have normal air which has a higher concentration of oxygen, nitrogen, and it can react with the sulfites and the sulfur and the nitrites and the nitrates within the wine itself. So having argon gas within the gap of the air that we breathe and the wine that we consume, it keeps the wine from changing its chemical state. Another thing that argon is used for is in document preservation. So things like the Constitution, or things like in museums. If you visit a museum, you'll notice that some things are kept within a box-like container that have air within it, but it's not the normal air that we breathe. It's actually argon gas. It's a combination of inert gases that do not react with the material that is trying to be presented, and that's an advantage because it allows the document or the materials to be preserved in ways that wouldn't be possible in normal atmospheric conditions with all the types of airs and gases that have the potential of chemically reacting with the document and further increasing its rate of decomposition, because paper is made of cellular structures that were once wood fibers and wood starches that over time decompose and degrade because time causes them to not be as structurally sound as they previously were when they were originally made in nature. Argon gas is also used for light bulbs. It's what's used to fill up the light bulb for the filaments that eventually glow when injected with high amounts of voltage, because the filament is usually a metal such as tungsten and doesn't melt at high temperatures or high voltages, because at high voltages metals have the potential to heat up a lot, and that causes them to oxidize with the environment, and that causes them to potentially melt. But since tungsten has such a high melting point, it doesn't have an issue with that. The only issue that tungsten has that is an obstacle in terms of creating something that glows is that tungsten oxidizes with the air if it gets too hot. And if tungsten oxidizes, it can't remain glowing enough for us to be able to see, because if there's no tungsten glowing, emitting excited electrons due to the high voltage electricity, then we can't produce light that allows us to see at night. So what we need to do is remove all the oxygen from the air to to prevent oxidation of the tungsten as it heats up from the high voltage current that passes through it. So we remove the oxygen from the air and replace it with nitrogen, argon gas, or sometimes a mixture, and that allows us to be able to place the tungsten filament and seal it in within that container. And then when we shoot up high voltage current, it's unaffected and unoxidized by the surrounding oxygen that exists outside of it, because the oxygen is unable to enter because it's a vacuum, leaving only the element argon within, and sometimes nitrogen. As mentioned previously, argon is used as an insulative material that is inserted between things such as glass panes that prevents heat from being transferred or from leaving the desired regions of the house, and that allows us to be able to stay warm during the winter and stay cool during the summer by preventing heat from leaving too quickly when we want it to be warm inside, and from entering too quickly when we want it to be cool inside. And that's one of the benefits and advantages of the element argon. Here is another image of argon and its use for winter and summer. So in the summer, solar heat and UV rays stay out, and in the winter, home heat stays in, and that's the whole purpose of insulation. Here is another image of that insulation. Argon, being a gas, has the potential to preserve things and replace and displace the current air that we use to breathe, and that's an advantage for wine, and it's also an advantage for gas canisters that we use to breathe underwater, because underwater the pressures are much higher. And I didn't mention it previously with the helium episode and the hydrogen episode and the nitrogen episode, but all those gases are used in different combinations and different amount of concentrations to mix up within the breathing tanks themselves that scuba divers use to breathe underwater, because based on how you mix up those gases is how well or how unwell the scuba diver feels when they try to breathe in air underwater, because different amounts of concentrations of helium to hydrogen to oxygen and to argon allow the breather to be able to breathe in that oxygen that their body requires without breathing in excess amounts of gas that could cause bubbles to accumulate within their body and cause a lot of trouble that resemble the symptoms of being drunk underwater, which is very dangerous, because that could cause a scuba diver to remove their gear or perform unprofessionally and dangerously. So argon is important as a gas that we use to breathe. It's mixed with the oxygen and the other various gases that are used in combination. It's mixed with oxygen and other various gases in general, and it saves a lot of lives. So that was argon explained in 14 minutes or less. If you're interested in watching the previous video, it was on carbon explained in 25 minutes or less. That's also a very important video I suggest watching, because carbon is a very important element in not only the human body but also in the universe. It's created in stars. It's a very complex process. It's unlike a noble gas that doesn't react with any element or doesn't react with even itself. Carbon reacts with itself very much. It creates various bonds, it creates various molecules, and it creates various compounds with other atoms on the periodic table. So it's a very interesting and complex element that contrasts greatly with the argon element that we just discussed today. So if you're interested in watching that video, click on the description below. Other than that, please make sure to like, comment, and subscribe. Thank you guys for watching. Have a good day.